Okay, let's go over your mock final exam number 3. Okay, now a researcher is interested in learning how age of people may affect motor learning. Okay, now he gathered 10 young men in their teens and 10 men in their 50s to be a part of his study. Then the researcher designed a new learning program in which the participants respond by pushing a lever. The outcome is measured by percentage of success rate in a given session. Now, the researcher had the participants repeatedly perform such tasks every day for 7 days. The following graph depicts the results obtained from this study. Okay, so let's take a look at this. So on the x-axis, you have the number of days. Okay, so that would mean this is the first day, second day, and this is the day number 7. And on the y-axis, you have the success rate, and on the legend, you have young versus middle-aged men. Okay, now answer the following question. Okay, so what are the independent variables? Well, the independent variables is first age of the participants, young versus middle age. Okay, and the second one is the days in which that they are learning, basically. Okay, so the duration of learning, if you will. Okay, and now what is the dependent variable? Well, the dependent variable is over here, the percentage of the successful rate during the lever pressing task. Okay, now what's the design of the current study? Okay, now we said that the not animals, the subjects, they had to repeatedly do the trial, right? So this is one trial. This is how they did in the first day, the second day, and third day. So they have to go through 7 um, different days, and in order to assess their learning curve, right? So that's repeated. Okay, young versus old man. Not old, but middle-aged men. So these are two different groups. All right. So this one is not repeated measure, but this is a between subjects design. So you have one independent variable when this one is basically not manipulate, but this one is repeated measure, and this one is between groups, right? So here you have a uh, mixed subjects, well, mixed design basically. Okay, so that's the first thing. And now the second thing is like, now are the number of days like manipulated? Well, you're not really manipulating anything, right? You're just allowing the subjects to learn. So therefore, you're not manipulating this. You just repeatedly letting them you're just doing assessment repeatedly. Okay, so this is not manipulated. And young versus middle age is also not manipulated. Okay, so this is a 7 by 2 mixed design quasi experiment. Okay, number 4, are the independent variables discrete or continuous? Okay, so the number of days. So you got number of days in day 1, day 2, day 3, day 3, day 4, day 7. So this is a continuous. Okay. Okay, so that's the first thing. And young versus middle-aged men, this would be discrete. Okay, so that's that. Now, what is the scale measurement of the dependent variable? Now, is there so this is the success rate, right? Now, can you have 0 success rate in which you just keep failing and failing, failing? So there is, right? There is a such thing, and then that would mean that this is an absolute 0. Okay, so that's the nature. So when there is an absolute 0, that means that this is going to be a ratio scale of measurement. Okay, now number 6, what is the ideal statistical test to analyze these results? Okay, so now we determine this is a um, mixed design, right? So what you need to do is you need to do a 7 by 2 factorial mixed ANOVA. Okay, So that would be the appropriate statistical test to analyze these results. Now, looking at the graph, all right, so the title, so the x-axis label should be, well, the number of days in learning. Okay, so that should be fine. The title should be success rate in lever pressing task as a function of age of the participants and the duration of learning. Okay, so that's how I would say it. Okay, now let's take a look at C. Okay, so besides the missing title, XY axis labeling, is there something inherently wrong with the graph? Okay, so there is something wrong with the graph in which that we said that because when you look at day 1, 2, 3, 4, 5, 6, 7, this is a continuous variable, and on top of that, the the subjects that are being repeatedly exposed to the actual task. So that means the y-axis is actually a repeated measurement, right? So this should be in a line graph format, not in a bar graph format like this. Okay. Okay. So basically, that's what's wrong. Number 8, is there an overall mean effect of practice over days? Okay. Is there? So now let's just look at the young men and as well as the middle age. When you are looking at their performance in day 7 versus day 1, this is the most dramatic difference, right? Is there improvement? If you just look at that, is there improvement? There is, right? So you can just say without a doubt that there is definitely the effect of practice or learning, repeatedly learning on this task, and how that actually affects the success rate. So there's an overwhelming effect of practice over days. Okay, number 9, is there an overwhelming effect of age on learning? Okay, so now let's take a look at this. In day 2, day 3, we don't see that much difference at day 7, but what is going on in day 3? Day 3, the effect of age is actually very dramatic. All right, so in 4 out of the 7 levels, you are showing there is a significant difference when it comes to the success rate in young versus middle-aged men. Okay, so with that said, we think that there should definitely be a significant differences when it comes to the actual effect. Okay, so number 9, there is by just looking at the graph, there is a significant overwhelming effect of age on learning. Okay, number 10, is there an interaction effect? Well, there is definitely an interaction effect because when you just look at something like the differential differences in day 1 versus, let's pick out day 3, day 4, or day 5, you can see that young versus middle age is not significantly different here, but it's significantly different in the level. Okay, so that means that there is definitely a significant interaction effect. Okay, now let's go to the next one. Which group has the highest variability and the lowest variability? Okay, so highest variability is definitely the one with the biggest error bar. So that is the young men's group in day 4. And the smallest is going to be the middle age uh, on day 5. Okay, because this one has the smallest error bar. Okay. Number 12, looking at the simple mean effect, on which days did age differ in the motor learning performance? Okay, on which days were they similar? Okay, so day 1, they were similar, young versus middle age. At day 2, they were still a little similar, but you can see that disparity you can see the trend start to get separated out. By day 3, you start to see a difference, right? Young is outperforming the middle age. At day 4, that this effect of young outperforming the middle age persists and persists into day 5, persists into day 6. But then eventually at day 7, this is no longer true, in which that there is a significant catch up in the sense that the middle-aged men eventually they were able to get to the same amount of successful rate um, that the young men were able to get. Okay. Now let's take a look at over here. Okay, number 13, by just looking at the graph, how does the improvement rate differ between young and middle-aged participants? All right, so let's take a look at the young men. Okay, just looking at their performance, you can see that they go up very quickly, right? And then so you can see that in day one and day two, you see a significant increase just in the young man. So you see that there is a significant increase, and from day two to day three, there is another significant increase. And at day four, you see an increase, or you don't know if it is significant. This is probably not significant due to how large this variability is. But at day four and day five and day six, you can see that there is a plateauing. They reach the maximum. They're not improving anymore. So you can see that the slope of going up is much faster in a young man. Now, when you look at the middle-aged men and in terms of their learning, you can see that their learning is not as quickly. So because when you look at day one and day two, they're not significantly different, and day two and day three is not significantly different. But when you look at day one and day three, you start to see a significant increase when it comes to the success rate, right? And then at day four, you start to see you start to see significant amount of improvement, but not comparing to the day previous to that. Because when you look at day one versus day two, not significant. Day three versus day two, not significant. Day four versus day three, not significant. Day five versus day four, most likely yes. So you can see that the curve of learning is not as dramatically saturating as the young men, but compared to in the middle age compared to the young men. So which means that the middle age men, they are still learning, but they're just not learning at this fast pace that the young men are learning. But eventually, do they get all with a significant amount of practice at day seven? Do they all uh, become proficient in this motor task? Yes, they do. Because at day seven, then young versus middle-aged men, they are not differing from one another. Okay, it's just that this rate of going up, I mean increasing in young versus middle-aged men are different. Okay, in which the young men learn faster compared to the middle-aged men, but both eventually gets to the same level. Okay, which number are we? Okay, so number 14. If you are the research scientist, what would you do to increase the internal validity of the study? Well, I would definitely include females, right? And I would probably want to, oh, sorry, the internal validity. All right, so maybe uh, how would I increase the internal validity? Okay, so the internal validity can be increased by actually making stricter, and also you should do something like more standardization. So now something that this narrative did not say is that we don't know when they're being tested in a day, right? So I would standardize exactly the same time of the day that they're being tested, or you can do something like I'm going to standardize things like the amount of um, food that they have their stomach, or the amount of their caffeine. So I want to standardize and hold the conditions constant as much as possible across days. Okay, so that's the first thing that you can do to help the internal validity of the study. Okay, okay, B. How would you increase the construct validity of the study? All right, so the construct in here, we are we are trying to see the effect of motor learning, right? So the construct validity, it doesn't really say anything about the validity of this pushing the lever kind of motor learning as a way to gauge motor learning. So should definitely first establish the validity for the actual instruments that we are trying to look at. Okay, so that's a way to improve construct validity. So you can compare this test that you develop with other motor learning measurements to see how much they match up from one another. So that's a way to increase your construct validity. And how would you increase the external validity? This is when you would kind of include the females, okay, of the to also be part of the study. And if you also want to do interested in effect of aging on motor learning, you should also not only include the middle age, but also include like older age. Let's say maybe folks that are 70 years old and above, and maybe if you can gather this kind of participants, some people who are very, very old, like in 100 years old and plus. Okay, so these are all the ways that you can do to increase the external validity of the study. Okay, now I think that's a wrap. Okay, that's it.